This question is the Edexcel June 2024 GCE Level 3, Paper 1, Question 13. The question states, given that A is a positive constant, use the substitution x equal to a sine squared theta to show that all that is equal to this. B. Hence, use algebraic integration to show that this is equal to a constant pi a squared, where k is a constant to be found. So x is equals to a sine squared theta. If I differentiate x with respect to theta, I'm going to get dx is equals to 2a sine theta cos theta d theta. So I've just done chain rule mentally. So this goes down to multiply that to get 2a. I'll reduce this power by 1. Then I'll differentiate sine theta, which is cos theta, with respect to theta. So now I'm going to write x to the power half in terms of theta. So I'm going to get x to the power half is equals to square root of a sine squared theta. And that will give me a to the power half, and the square root of sine squared theta is sine theta. I'm now going to also write square root of a minus x in terms of theta. So if I do that, I'm going to get square root of a minus x is equal to square root of a minus a sine squared theta, because a we know is equal to a sine squared theta. If I simplify that, I'm going to get square root of a bracket 1 minus sine squared theta. So this can be simplified to square root of a cos squared theta, because we all know that cos squared theta plus sine squared theta equals to 1. And so this can be written like that. We can now reduce that to give a to the power half cos theta. So now I'm going to rewrite this, by this time in terms of theta. So then I have integral of x to the power half square root of a minus x dx is equal to integral of the x to the power half becomes this. So I have a to the power half sine theta. The square root of a minus x, as we know, is now this. So times a to the power half cos theta. Now dx, as we know, is equals to that. So times 2a sine theta cos theta d theta. So now all that has changed from x, rewriting this in terms of theta. What's left is the limits. The limits for this is 0a. And we know that x is equals to a sine squared theta. We will now go and draw a small table here like this to find the corresponding theta values of x for 0 and a. So if I put the x values here and theta over here, I'm using this equation here. When x is equals to 0, we have 0 is equals to a sine squared theta. And this implies that sine squared theta equals to 0, and therefore sine theta is equals to 0. And if I find the sine inverse of 0, I'll have theta equals to 0. So when x is 0, theta is equal to 0 as well. And then when x equals to a, we have a is equals to a sine squared theta, which also implies that sine squared theta is equals to 1. Square root of 1 is 1, and so sine theta equals to 1. And sine inverse of 1 is equals to pi over 2. And so when x is a, theta is equals to pi over 2. And so we can now put the limits in. So this will be when x is 0, that will be 0. And when x is a, that will be pi over 2. So we are now going to simplify this. So now I have a to the power half times a to the power half is a, and a times a is a squared. So what I have now is integral of a squared, which we got from this, and that. And then we have sine theta cos theta. So we have sine theta cos theta. And then we have 2 sine theta cos theta. And if we use this identity, we have sine 2 theta is equals to 2 sine theta cos theta. So 2 sine theta cos theta is what we've got over here. And so we can now replace 2 sine theta cos theta by sine 2 theta. So let's do that. I'm going to get sine 2 theta. And then we have our d theta over here. I can now rearrange this to get half sine 2 theta is equals to sine theta cos theta. So I can go replace the whole of that with half sine 2 theta. So if I do that, I'm going to get integral of a squared times half sine 2 theta times sine 2 theta, which is this one here, and then d theta. So our limits again, 0, pi on 2, 0, pi on 2. Our sine 2 theta times sine 2 theta is sine squared 2 theta. I can now write the whole of this as follows. Half, which is a constant, a squared, which is also a constant, the integral of sine squared 2 theta, and that is this times that, d theta, and the limits will be from 0 to pi on 2. And that's exactly what is required over here. And so we've just shown that this is equal to that. So now for B, hence use algebraic integration to show that all that is equal to a constant k, pi a squared. So if I take the left-hand side is equals to integral of x to the power half square root of a minus x dx from 0 to a. This we know can be written as theta, as proved in A. And so that is equal to half a squared integral of sine squared 2 theta d theta from 0 to pi on 2. We are now going to resort to trig identities to simplify this. And the trig identity that comes to mind is cos 2 theta is equals to 1 minus 2 sine squared theta. And this is a double angle formula because this is double that one. So we can say that cos 4 theta is equals to 1 minus 2 sine squared 2 theta. 4 theta being double of that. Now if I rearrange this, I'm going to get 2 sine squared 2 theta is equals to 1 minus cos 4 theta. And so sine squared 2 theta is equals to 1/2 of 1 minus cos 4 theta. So now I can replace sine squared 2 theta with half brackets 1 minus cos 4 theta. So let's do that. So that will give me a half a squared, which is here, an integral of a half brackets 1 minus cos 4 theta d theta from 0 to pi on 2. A half times a half is a quarter, And so that gives me 1/4 a squared 1 minus cos 4 theta d theta. And now this is very easy to integrate. So if I do that, I have the constant 1/4 a squared. If I integrate, I'll get theta for this. And I'll get minus 1/4 sine 4 theta for this one, between the limits of 0 and pi on 2. So now I'm going to put these limits in. And if I do that, I'm going to get 1/4 a squared. Pi over 2 here will give me pi over 2 minus 1/4 of sine 4 theta. If I find sine 4 and theta is pi on 2, that gives me sine 2 pi, which is equal to 0. So it means I have 0 here, and now I can put in the 0. So 0 into theta gives me 0. If I put 0 here, I'll have sine 0, which is 0. And that gives me 1/4 a squared times pi on 2. So if I simplify this now, I'm going to get 1/8 pi a squared. So this implies that k is equal to 1/8. And that is the solution for this question. Thank you for watching. See you in the next video.